Hello and welcome. In this video, I will introduce you to the workflow for MVTec HALCON's new shape-based matching operator set called Generic Shape Matching. Here, I have prepared an H-developed script in which we try to find circlips like this one using generic shape matching. Right now, the script only displays a series of images. The generic shape matching workflow can be divided into 2 offline steps and 1 online step. The offline steps are 1. Create the shape model, and 2. Train the shape model. The online step is to find the shape model. For the first step, we call the operator Create Generic Shape Model. This returns a model handle. This model handle can be examined using the Handle Inspect. All shape model parameters can be seen here. Let's move it on top of the program window for better visibility. For now, most model parameters and a few of the search parameters are set to auto. Note the parameter Needs Training is set to true if a model needs training. This is the case for newly created models like this one. However, this is also the case when a training parameter of an already trained model is altered. Since Needs Training is true, we need to train our model. For this, we need a template of the shape we are looking for. You can either use an image or XLD contours. In this example, we're going to use an image. The image must clearly display the shape of the searched object. In our example, the object displayed on the image with the index 0 is a perfect template for our shape model. To get only the edge information of the desired object, and thus exclude irrelevant edges, we reduce the domain of our reference image. To do so, we first need to define a region of interest. This can be done by clicking Create New ROI on the top of the graphics window. After defining an ROI, we reduce the domain of our image accordingly. The shape model can now be trained with Train Generic Shape Model. After training the model, we shift our focus back to the model handle. The parameter Needs Training is now set to false. Additionally, all parameters previously set to auto have now been set to fixed values. Changes within the model handle are highlighted in orange. With this trained model, we can move to the next step and find the circlips inside the other images. This is done by calling Find Generic Shape Model. Find Generic Shape Model returns the number of found matches and a match result handle. This match result handle contains every result of our shape matching, organized by matches. To visualize the results in the graphics window, we can use Get Generic Shape Model Result object to retrieve the contours of the matches. As we step through our images, we can see the match result handle updating itself for every image. The generic shape matching finds the matches correctly, even with changes in the illumination. This is because shape matching is based on contours and not gray values. Even multiple matches are found with the default parameters. In this image, slightly smaller objects are not found because the default parameters of the generic shape matching doesn't allow for any type of scaling. This is also evident within the model handle. Since scaling is part of the training parameters, it must be set before training the model. In this case, the circlips we'd like to find are smaller, isotropically scaled versions of our model. Thus, we call set generic shape model param and set isoscale min to 0.7. This sets the parameter needs training to true, so we must retrain our model. See also scale type, which is now set to isotropic. Retraining our model sets needs training back to false. After adding just one line of code and training our model once more, all matches are found. This concludes this video. You should now be familiar with the generic shape matching workflow in MVTec HALCON and with how to adapt your shape matching to your application. The next step could be to accelerate the search by reducing the domain of the search image or by limiting the search space by parameter tuning. Thank you for watching.